Hello, this is Jarvis Klein, and welcome to session number 5 in our video series to develop a utility for planning aerial survey missions, or at least for calculating some of the parameters useful when planning aerial survey missions. And where we were is we have the main user interface for our program. We can define the instruments that represent our aerial survey platform, and we have several different modes of providing the input into the calculations. And then what we want to do is have the program generate a report that will tell us a summary of all the information that we designed this program to help us calculate. So, basically where we are is we are at the stage of implementing this button. So what I wanted to have happen when the user enters in the input parameters and clicks the button is that will pop up, I guess, another window with a little report, and the user can review the report or save the report and maybe run the program multiple times to compare different settings. So I guess that puts us kind of at a input validation step where we're going to need to produce the inputs. So probably what we'll have is a utility class that will do the calculation to generate the report, and the inputs will probably be provided as a special input object type, so that when you generate a report you just provide a populated object with all the input settings. So that's where we are, I guess, is we need to generate that object that has all the input settings and validate it and go from there. So maybe there's one more subfolder here which is going to be not there. What report generation? Let's see. So let's start by making a class that represents the inputs. Let's see. So, in all cases, the user is going to provide the. It's not really. I want to just run the program without engaging the debugger. Where would that be? So we might specify the input mode, but let me just start with easy stuff, I guess. We're for sure going to have a list of instrument configurations. And we'll have the terrain parameters. So for each of these inputs where I allowed the user to specify using either one of two units, so I allowed a specification either in feet or meters, in each case I need to choose a canonical form. So for example, I'll probably just choose to represent the input as if the user had provided feet. It may be a result of converting the user's input from meters to feet. The alternative would be to have a small data structure that defines both the value and the units. So whatever unit the user actually entered it in, we could record that and be slightly more precise about things. But simpler, probably just to record it in one of the two forms. So let's go ahead and record the elevations in feet, because aviation works on feet, so this should always be provided, so min terrain elevation, max terrain elevation. In all cases, we're going to provide the speed. I guess the canonical flying speed is in knots, so... and, you know, it's relative to ground, which I assume should be obvious. Should we add a little label while we're thinking of it? Maybe we could add it to our little label here. Note flying speed is considered relative to ground. Note that the relevant speed for this program is ground speed, not airspeed. I don't know, is that too wordy? Note that by flying speed we mean ground speed. I don't know, let's see. Note that by flying speed you mean ground speed. How's that? I don't know if there's room for that on the user interface, but oh well. So back to where we were. Flying speed in knots. Don't need to see that, do we? As well. I guess we'll have an enumeration for the mode, so mode 1 is flying speed, input, speed, height, mode 2 inputs are speed, height, overlap, for selected instrument. Speed and desired resolution and overlap. Something like that. So, what could I say? I could just say if mode 1 or 2, height, flying height means sea level, feet, right? And if mode 1, line separation, meters. If mode 2, overlap for selected instrument, percent. If mode 3, and as well as one specially selected instrument. So if mode 2 or 3, selected instrument. If mode 3, we have the speed, desired resolution, and this is also kind of a little structure. Maybe I should have a little structure for this. Desired resolution. So we have several modes here, I guess. One is, for example, lidar point spacing, considering single pass, i.e. without overlap, i.e. before overlap. Another is lidar point spacing after considering overlap. Another is what did we have? Where's my... That was... looked inconsistent for sure. What was that? I was in mode 3, but I was saying mode 1. Can I duplicate that? It's an odd glitch. Well, anyway, if you have a camera, then you've got your pixel size in whichever axis, and then whether that should be achieved over the highest terrain or the lowest terrain. So it's kind of 4 different settings. So let's say pixel resolution, point spacing, this is centimeters. Maybe a separate enum. Well, guess I can do all 4 cases. Pixel resolution, x-axis, or a cross track. Yeah. In the cross track pixels over max terrain. Pixel resolution, the along track pixels over max terrain, and the same thing over min terrain. So these are our 4 options for the camera and a couple options for lidar. Resolution mode, no specification mode, and a value. Whatever it is from this list, in all cases it's centimeters, but I guess lowercase one out in the end there. So you've got if mode 3, desired resolution, and desired overlap. Which I guess that could again be if mode 2 or 3, huh? Overlap. Well, that should cover it. So let's write a function in our main user interface that will either generate this, a well-formed object of our input class, input parameters class, or generate an error to tell the user what the problem was. So let's do it. Guess we'll need to add our handler for the calculation button, so let's go ahead and get that. Let's just say there's the handler, we'll deal with that later. Meanwhile, we have a utility function. What I may do is one moment. Or, well, then that'll be 2 steps. I guess what I actually want to do is have a function that returns a small structure that contains either a result, and if the result is an error, we will advise the user of that, or if the result is a success, we will have a well-formed input parameters object. So because we have kind of 2 return values, I'm just going to return a small tuple. So I have a class which I just call struct2, which is like a tuple. It's pretty much the equivalent of a system tuple, but I implemented my structure class before tuple was added to the .NET framework, as well as I prefer to just specify the number of parameters. So it's a structure with 2 parameters, and we'll have a result as the first parameter. And if successful, the object. So GUI level is a prefix I was going to use to indicate a function that can interact with the user directly, such as generating a message box, but I'm restructuring the return type so that it won't need to prompt the user directly. So I'll just say private utility, and I guess I'll get a return object ready. So let's see if the user has entered everything he needs to enter. First we need, I guess we'll go by the radio button, we need an input mode checked. So I'll just go by the radio button, then local parameters, I don't know. If that's true, then the input mode is mode 1, and whatever else. And the input mode is mode 2. You know, just because of that strange behavior we saw before, where else am I testing the input mode? I guess what I should do is just have a property of this form. Let's see. Maybe it can be around here. And the property will just return that enumeration of what mode we're in. I have to find the enum here, so I'll just use that. Current input mode. Or null, I guess. Which means I have to make it a reference enum. And what I want to do is do the testing. Back to where we were. Sometimes I use undo and redo in quick succession as a shortcut to get back to where I was just a moment ago. There's also the Control minus shortcut in the Visual Studio Code Editor to go back a bit. But what I want to do is I'll do the test by the radio button, but if it doesn't match what we expect from the main tab, so if there's some type of mismatch, this should never happen. Error, there is a program error where selected radio button does not match the displayed tab, parameters tab. And then let's just try to fix the problem. By saying I guess we could do that. And I'll return null, and this should never happen. If it does, the problem will probably recover because we'll just be testing for null wherever this happens, and then maybe do a form refresh or something. Maybe I could do that here. But otherwise, mode 1. Basically, mode 2. Mode 2. I don't really like when error handling code is just kind of repeated and then this gets kind of long. But oh well. Otherwise, if there's no radio button clicked, let's just go ahead and return null. If I clear the file that persists our settings, then what happens? So it will show mode 1 here without having it checked. And could fix that though by just saying that the default selection on this is true. I'm using a custom property to mark it as selected by default because rather than the checked property because it's going to load from the configuration file that it persists the last used setting what it is. And then when our program does start up, we do a refresh form. So in our onload, and that just goes ahead and makes the tab panel match the radio button. So that's good. I mean, I guess we could also have it go the other way, where if there's no radio button selected, then if the tab panel a little redundant, but just going ahead here. So there's two things that need to match. If one is set, if A is set, it sets B. Otherwise, if B is set, it sets A. So in either case, they should just match each other after that. And this may never happen, but so that would be an example that if you're doing code testing coverage, you may have put some handling there that will never get tested. That's alright. So we have our property that returns what our current input mode is. And we could use that, I guess for sure we use it when we click the button. Where else are we doing that test? To see what mode we're in. Alright, well, we're just back to producing our input parameters object, so let's do it. If this current input mode, yeah, let me test it this way now. First of all, if it's null, then we have an error, which is, tell you what, let me do it this way. No input mode. Please select your input mode by clicking one of the radio buttons. So we'll have a result object, which is the error, and then we can just return null for the parameters, because if it was an error, then we don't have well-formed parameters. And otherwise, I guess we'll just call it as a property. Oh, I can't resist, I'll make it local, this current mode. Whoops. There we are. Just because it's a property, I don't like calling it twice, especially if within an if statement or a switch. So I'd rather save the local variable and then refer to that. So else if we're mode 1, well, we could just directly say equals local mode value, and it should be valid. So now we know what mode we're in, but we actually still need to do the test, don't we? So in that case, mode 1, mode 2, mode 3. I can follow the logic here in this case of throwing an error, but this would be an assertion failure. So I'll say programming error, assertion failure, unhandled enum, local mode val. So here's mode 1, otherwise mode 2, otherwise mode 3. And if we are in mode 1, then we need to set if mode 1. Well, in all cases, we set the flying speed. So, we can do that here, I suppose. We need to get it from... We do actually need to get it from the corresponding edit box, so this will happen within the test. If it's edit mode 1 flying speed, so that wasn't right, was it? Flying speed, knots. We could make it... We're into the same situation we encountered before of how much error handling do we want to have if the user has entered, garbage or something. Or if he enters, we need the user to provide a flying speed in knots. So if it's 0 or negative, we could have a special message or just say there was an error parsing it. So what should we do? Well, I guess we could kind of go all out here and say we'll parse it as a double. If the flying speed is null, then we say please provide flying speed. Else, if the flying speed is less than or 0, we say please provide a positive. So what do you think? It's wordy. The error handling's gonna have a few lines of code, but I guess it's the nicest behavior, or I don't want to make it programmatically simple at the user experience expense, so that's flying speed. If it parsed out okay, then the parameters flying speed is equal to our local flying speed. And then the next input for mode 1 is, why don't I just run the program again? Flying height means sea level. So, flying speed, just going to replace speed with height. flying height isn't knots anymore. Flying height means sea level meters or something. Feet means sea level. So the flying height, if it's null, please enter the flying height. If it's less than or equal to 0, well, I don't want to have that restraint. I mean, user may just be using the tool in a way that he sets the terrain really negative and the height really negative. But what we would have as an error is if the flying height is not at least greater than the minimum terrain. So I guess that's one thing we need to parse, and we can do that up here, is parse the terrain elevations. So, terrain, min terrain elevation, feet. Terrain minimum elevation feet. And if that doesn't parse, please provide the minimum terrain elevation and max terrain. I don't know, min t, max t. That didn't work here, did it? Maximum. Max. Please provide the maximum terrain elevation. Guess I'll set these as soon as I parse them. Min terrain. So when we come down here and we parse a flying height, if it is, I guess we could also make the user specify a max terrain greater than the min terrain. I mean, it's sort of just we have two different heights, and we'll calculate certain parameters for each one, and it's but so although the program would still work and everything, I guess we can make it an error if the min terrain is greater than the max terrain. Error. The parsed max terrain, min terrain was higher than the max terrain elevation. So now we know that the minimum terrain value is the minimum, in fact. So we'll test here that the flying height needs to be above the minimum terrain. Please enter a flying height that is greater than the terrain elevation. Or rather, sorry, I should be testing against the max terrain, shouldn't I? The max terrain elevation wouldn't be safe otherwise. Let's see. Actually, I just don't want my calculations to not work. So, let's see. But if that does check out, then the parameters flying height, mean sea level above feet, flying height, and the next parameter is the flight line separation. So That again will be something we test for 0. Instead of knots, we have meters. And instead of speed, it's line separation. Let's see. Flight line separation. If it's null, please provide the flight line separation. If this is less than 0, then our calculations are not going to work. So please enter a positive flight line separation. This is really flight line separation rather than flying line separation. And if that works, then if mode 1, line separation. So that should be all the parameters for mode 1. Moving on to mode 2, we did set everything, right? We've set the mode, we set the min terrain, max terrain, speed, flying height, and line separation. Mode, min terrain, max terrain, flying height, speed, and line separation. So that checked out. So mode 2. The parameters on mode 2 are again the flying speed, so we'll take that. From the mode 2 edit box, edit mode 2. Then next is the flying height above sea level, which is also the same as the first case, so this is reused, but with the mode 2 edit box. And a selected instrument, so let's grab the selected instrument, combo box. Selected item. It's an instrument configuration. I guess what I can say is directly assign it using my parameters object, but if that were null, so it shouldn't be null, then we have an error. User validation error. Please select an instrument in order to use calculation mode 2. Please select an instrument for which you wish to specify the overlap. Otherwise, we've assigned it, and lastly we need to parse the desired overlap, so mode 2, desired overlap. And again, we'll have some handling. If it's null, then please provide the desired overlap for the selected instrument. Otherwise, if it is, I guess we could make it work with something less than 0, in which case I'm going to prompt the user, in which case I'm going to make this a GUI level routine after all. So GUI level is just my prefix as a heads up that this function might prompt or interact with the user. So if the user has entered a value of below 0 overlap. Then let's just make sure that's what the user wants. What can we say? You have entered an overlap value that is less than 0. Is this what you want? Confirm overlap. Yes, no, or cancel. If the user doesn't say yes to that, then we just say that it's been cancelled. Otherwise, we fall through and proceed, and we can assign the if mode 2 or 3 desired overlap. That was the last parameter, A. So coming to the third case, and we've assigned how many? 1, 2, 3, 4. That's right. Coming to the third case, you have speed, which is just the same. Some of these are going to be the same. Maybe I'll copy this whole thing because then just go carefully through it. So speed, using the edit box from mode 3. Let me just do that. We are not specifying the height in mode 3, we are solving for it, but we do have a selected instrument for which you wish to specify the overlap and resolution. Take a short break. And we're back. And we were saying that he selects an instrument. What's next? I guess we can say that the overlap is the next thing in the flow of this form. So the overlap, but is going to be coming, oh, right, this is coming from mode 3. Then the overlap in mode 3 will still prompt if he has a value less than 0 for the overlap. We'll just make sure that that is intended. And finally, speed, instrument overlap. Finally, we need to figure this out. So really need to fix the layout of this form while I'm thinking about it. I need some more room in a couple places. So one place where we could use some additional room is this box, which is just coming up a little short. We use the same values. Location. Oh, what happened? Come on. So why did that not copy? Ah, missed the 2 prefix there. There's that, and the size. Oh, whoops. You know, I haven't backed up my source code recently, and I should probably do that. I just always get reminded to do this when I'm working with the designer, because I'm just afraid, maybe from past experience, that it's going to corrupt my work, even though maybe that's not fair. I don't know that I've had that problem at all recently, but and so let's see if that's enough space, but also I need more room for these labels here. So I guess I just move these to the left. Maybe collapse these fields a little, and that'll give a little more room here. I mean, I don't want it to be so far away from these radio buttons. So maybe what I'll do is I'll just center the labels so that they can bridge the gap from here to here. So what's the text align? Well, in the end, if everything checks out, we're going to return a success with the parameters. So, if I select an instrument now, we say desired resolution, pixel size across track, long track. I have slightly more space than I really need. I guess it's okay. Oh, maybe I'll reduce it just a little. Probably reduce it just a little. What was that button anyway? I feel like these should be a little more level with the, let's see. Bring it back just a little. Maybe like that. Except I don't want that to clip there. I was hoping it would just not be allowed to show over the group box, but let's see. I wonder if a send to back will affect that. I forget. Perhaps not. So I really just need to trim it like so, I suppose. I guess I'll make them the same. So, moving on. We'll need to parse, depending on what radio button he has selected here, so... So, if radio button mode 3, resolution mode, if he's checked this button, else if he's checked this button, else he needs to check a button. Please check one of the radio buttons. Actually, these are the wrong radio buttons. I'm thinking of the ones that indicate terrain, so that's this one. Over the highest terrain. What comes first? Over the lowest or over the highest? So, over the lowest, the highest, and else. Sorry, return a result. Please check one of the radio buttons, indicating whether the resolution you have specified should be achieved over the highest or lowest terrain. And I guess we could have a kind of a third setting, which would be min terrain, max terrain, and like target terrain, and the terrain that represents most of the survey or that the user actually wants to plan for. But we'll just leave that for user feedback, so to speak. If our users want that, we can find a way to incorporate it. So if it's this one or this one, then we will be able to parse it out. So I guess it's really more of a OR case at this point. And we get the value. Let's take it from the top edit box. So this is the top edit box. If it doesn't parse, we'll say please enter the resolution you wish to achieve with the selected instrument. If the resolution value is less than or equal to 0, then our calculations aren't going to work. So say please enter a positive resolution value. need to populate our return object, and it's gonna be one of several cases. So I guess I'll just say if if the selected object is a laser scanner, then I guess what we have is that input mode, desired resolution, and we'll set that at the end. But here we'll fill it up. If it's laser scanner, then the value, I guess in all cases we can set the value is going to equal the resolution value. If it's a laser scanner, then we take it as the lidar point spacing one way or another. So if it's this, then we say that the parameters resolution mode is lidar point spacing after considering overlap. That's what this says. Then it's lidar point spacing without considering overlap. Otherwise, tell the user he needs to specify. Please select a laser radio button for the laser scanner resolution. Please check a radio button indicating whether overlap should be considered to achieve the specified resolution. Something like that. Otherwise, if what was this? Let me go back to my object, because did I do that right? I guess the lidar would also have 4 cases, wouldn't it? So let's have 2 enums. Desired resolution, target terrain, target terrain enum over min terrain over max terrain, and desired resolution type specification enum, and this is just a cross track or a long track for a camera. Or with or without overlap for a laser scanner. And this could also be instead of storing this as an enumeration, we could store this as a double value, what the target terrain elevation is. But well, the other thing is we've got this. Resolution, specification, and side resolution, target terrain option. I just like something to indicate the enum. Sometimes I use option to represent an enum. So now that that's better laid out, we say that if you're a laser scanner and you've got one of these checked, you're specifying the specification mode. In either case, though, you're going to need the terrain mode. Maybe this comes first, so let's test for it first. So let's see. Actually, guess it's still within the test of a laser scanner. So if this radio button elevation mode is the lowest terrain. Oh no, we broke it out. Desired resolution over the lowest terrain over the highest terrain. Otherwise, please specify. Please check a radio button indicating whether the target, indicating over which terrain the target resolution should be achieved. If it's a laser scanner, we have one of these specification modes. And you know, really, we're already solving, I guess, the canonical desired resolution specification if laser scanner. Laser scanner. We're just going to say desired resolution value across track if camera across track pixels centimeters if camera let's say if laser scanner point spacing. Ho ho ho. You don't need this, do we? Because, you know, there's two ways the user might enter the pixel resolution. Either the pixel size along track or across track if he has an instrument that does not have square pixels, But either way, we can solve one in terms of the other. That's what we did last time. So we can just take this as the canonical form, for example, a cross-track resolution. So we don't need that. So, right, desired resolution value, if camera, cross-track pixels. I like it better this way, actually. Cross-track pixel size centimeter if camera, and lidar point spacing centimeter if laser scanner. Point spacing in one axis, not taking a hypotenuse. So let's see. If you're a laser scanner, you'll specify that. This resolution value is just going to be the resolution value we got from that text box, the units 1 text box. We have the terrain option, and then if it's a laser scanner, then we have and that should be it. And so, is there anything else? I think we've got it all. If it's mode 3, we're taking the flying speed, the selected instrument, the overlap that is desired, and then the resolution. So what are we doing here? If he has the terrain checked, yeah, I'm not sure why I structured that way. I can just take this out. Get the resolution that he wants. Then check that he has the terrain mode specified. Then check that the instrument type. If it's a laser scanner, check that he has the resolution mode specified. After considering overlap, or before considering overlap. And that's it. So, if we get through all of that, then we should have all the parameters populated, so we can return it as a valid object. So when the user clicks the calculation button, what we will do is call this function input parameters. If the input parameters first tuple item, which is the result, if it's an error, then message box out the message from that error. Otherwise, we can generate our report. So let's have a report generation utility. Report util, I guess. Or maybe just call it report. What I may do is have a report util and also have a report itself. So the report we're going to be generating is mainly just text, but we may provide different ways of formatting it. So one way we'll format it is just as plain text, but we might also provide it as a simple HTML report. And so I'm just going to have a little object that will allow us to write the report without caring how it's going to be displayed, basically. So let me say this. Generate report given the input parameters. And the first thing we would like to do is just summarize the inputs. So I think what we'll have is an add line. So first we'll say maybe a timestamp. Aerial survey mission parameters tool. Whoa, how should we say this? Maybe an add header. And then add a line, which is the date, or just a timestamp. Quick note about timestamps. It's always been annoying to me that timestamps don't usually specify the time zone. Like in email even. Even today in email correspondence, when you reply to someone, for example, it doesn't by default specify what time zone you're referring to, which is really annoying. But I guess I won't do anything to improve the situation. Year, month, day, hour, minute, second. So we'll just do that. And we'll say maybe a separator. And let's see. Let's summarize the input parameters. So let's say this could possibly summarize itself. You know, it's utility get summary paragraph. go with this for now. So let's see. Input parameters, maybe. We have input specification mode, which is, maybe I'll start by just saying instrument configurations and say from our list util we can get a summary of our instrument configurations. In fact, that's one thing we need to add to our object when we generate that object is parameters input instrument configuration list equals guess we can do this. Get the instrument configuration list. I feel like maybe we should just copy it for good measure, but actually we structured it in a way that we're okay. And if there are no instruments, that should actually be a problem. So that just happened. Please define one or more instruments. What is it? Using the edit instrument configurations button. Guess we can refer to it with the actual text and keep that synchronized. So back to our input parameters for the instrument. Let's just summarize the input settings. So min terrain elevation. Alright. Min terrain elevation. Max terrain. Input specification mode, let's say flying speed. This many knots. Guess we can summarize it in all of the different units. So what I may do is have a central location for everywhere we defined unit constants. Units, I guess. So we had done this in the main form, but now we're going to refer to them, the same constants, in other places, and I would like to put them in a central location. So conversion ratios. And And what's going to be left in the main form is now just conversion utilities. Everything should be static. What else? So conversion ratios, no. Just conversion utilities. Anyway. Back to our input parameters. So that's the speed in knots. And the next value is... I may make these properties. That would be convenient. So let's do it. Let's just say this train elevation in feet. Now we have meters. We'll return the feet times the conversion ratio. Alright, meters per foot, yes. And for min as well as max, go back. Min as well as max. Flying speed. Flying speed, kilometers per hour. Flying speed knots times kilometers per hour per knot. And also in meters per second. Multiply by meters per second per knot. Good. Various input modes. Flying height. If mode 1 or 2. Flying height meters. Return flying height meters times meters per foot. Line separation is in meters. I guess we'll just leave it there. I guess we could have it in kilometers as well, just for good measure. Line separation, kilometers. Which is the meters divided by 1,000. And overlap. We may not report this to the user, but it may be useful for ourselves later when we do calculation. Is we have the percent, but then a closely related unit is just as a fraction. So this, the fraction is equal to the percent divided by 100. The overlap fraction. It's idiomatic, having both fraction and percent. Percent being user-facing and fraction usually being more convenient for mathematics in the programming. So now we have min train elevation, this many feet, min terrain elevation meters. But now we need to round them. Oh, bother. Tell you what, though. Min terrain elevation meters string. And this is what? Convert this min terrain elevation meters using the same number of significant digits as we have in the terrain elevation as specified in feet, with a minimum of 3 significant digits at least. Ho ho ho. Then the max is just the same, but max. Why is that not defined? Oh, each one of these is a string. String. Oh, we probably don't need that one. But let's see. Kilometers per hour will be defined using the same number of significant digits as were specified in the knots, with a minimum of 3. Sounds okay. Then flying speed meters per second will have the same number of significant digits as the flying speed in knots again, but with a value of meters per second. And the flying height above sea level is reported with the same number of, this, using the same number of significant digits as were specified in the feet, with a minimum of 3. And kilometers, same number. Of significant digits as were specified in meters, with a minimum of 3. So min terrain elevation with just the meter string, meters. Why did it not like it? Max terrain elevation, sort of the same thing. Max terrain elevation meters. Then flying speed, ground speed. That's the value in knots. then kilometers per hour as a string, then meters per second as a string, then the input specification mode, mode 1, input speed, height, and flight line separation. Otherwise, mode 2, input speed, height, and overlap for selected instrument. Else if input mode equals mode 3, input speed and desired resolution, something like that. Looks like this was named imperfectly. The floating capital here. We're just back where we were in the same file, aren't we? Otherwise, didn't really want those brackets. So, actually, there's additional work in each one of these cases. So, flying speed, we've already got that. Height, I mean, logically this comes maybe before this. Maybe I will. It might read better. I don't know. Maybe. Let's see. Let's just say height. Which is gonna be what? Flying height. Meters. And flight line separation. This is flying height. I mean sea level. Flight line separation, if mode 1, the line separation in meters, or in kilometers. What's that? I guess that's that, and if it's mode 2, we've again got the flying height. And then we've got the overlap. Selected instrument, which is, let's just go by instrument name. Overlap for is gonna be 2 or 3. Overlap. Guess we'll just report the percentage overlap. Is there anything else in mode 2? I don't think so. If it's mode 3, then we again indicate the selected instrument. And the overlap again. But also the resolution, so we're probably going to have special handling depending on the type of instrument. So if mode 2 or 3 type, if it's a laser scanner, otherwise is it worth I almost want to do a calculation here to calculate both values. So for example, if it's a laser scanner, we only input this value, or we use this as the canonical form. We got this value. But we would also 0.18 centimeter is a lot of points per square meter, which makes sense because this is, 2 millimeter point spacing. But anyway, we got this. The user interface is already showing the duality of the two ways of specifying the resolution, but we would also like to recover that within our input object, input settings object. So I guess the place to do that is going to be in here. So if laser scanner num points per square meter, and I want to do the same calculation that we did in our main user interface. So we had a utility function that did this, and what we may do is put this into our units util, units and conversions. How's that? So now we have a function convert point spacing, right? Convert lidar point spacing in centimeters from lidar point spacing in centimeters to num points per square meter. Which is going to do the same thing we did before. Consistent naming on my part, that was the same, but anyway. Points per square meter, and return. So now we'll call that function where we used it. needs to be a static function. Convert our point spacing in centimeters to points per square meter. Since we're doing this, I'll go ahead and get the function that goes the other way. So let's see. It's gonna be from this to that with an arg points per square meter. And then the value of this is going to be one over the square root of the num points per square meter. Then get it to centimeters and return that. So we'll use that here. Convert from num points per square meter to a point spacing in centimeters. So back to where we were. If it's a laser scanner and we're looking at the num points per square meter, we have our conversion function. Convert from point spacing that should do it. And I may do a similar thing as we did before of having a string version of this for convenience for outputting. This is going to be convert this value to a string using the number of significant digits in this value subject to some minimum. Three is okay, or maybe 2. But that's alright, I'll give the third, so it'd be like 40.4 points per square meter, for example. And then we'll need to do a similar type of handling if it's a camera. So if, but it's going to be, but I need information about the camera, so I could make it a function. If camera with a long track pixel info, get a long track pixel size in centimeters, which needs the select instrument. Which is really a camera configuration. I guess I'll just say that. Type. If it's called with a camera type, with the instrument type that is not either a frame, well, tell you what. If you call it with the frame camera, we'll do one thing. Actually, no, we have properties that abstract the difference between frame cameras and push broom cameras, so how about this? Let's just say if it's not a camera, then we have a problem. So if, tell you what, one more property to our instrument configuration. Is it a frame camera or is it a push broom camera? So then we'll test here. If it's not a camera, then tried to retrieve a long track pixel size for instrument which was not a camera. And actually, similarly, if our camera configuration, if it does not have the information about the pixel size in the along track direction, then it's similarly a programming error. Pixel size for camera which did not have along track pixel information. Otherwise, we have everything we need to do this calculation, which is going to be, we have our ratio of pixel size x over pixel size y. So x was the across track. So just to simplify this, across track pixel size centimeters, then along track pixel size centimeters equals this, I guess, divide by the ratio. Divide by, yeah. Turn that, and then we'll have a string version of this as well. If camera with a long track pixel info, get a long track pixel size centimeters, string, again, return one of these, convert this value using the same number of significant digits as we have in, you know, this big long named value, subject to some minimum. 3 is probably okay. So now we can output all of that. One moment. And we're back. So, if you are in the mode where you select an instrument and specify the resolution that you want for it, if it is a laser scanner, we'll specify that the desired resolution is num points per square meter. This big long thing. Centimeter point spacing, or if laser scanner, num points per square meter as a string. Num points square meter. We'll see how that looks when it gets output. Otherwise, if you are if you are a camera, sorry, pixel resolution, let's just say the across track point spacing in centimeters, pixel size across track, and the centimeter pixel size along track. I mean, if they're square pixels, maybe we don't need to report it separately. But I'll just implement this nonetheless. There's actually going to be one more interesting parameter, and we could have it as a feedback for the user. Is there anywhere to put it in the user interface? If we know the height and speed, we could indicate the pixel blur, but we've got different instruments, and so if he selects the instrument here, we could indicate the pixel blur. We could, prompt the user for what resolution, what height he's going to get. We could kind of interactively prompt him, and maybe we would use this space right here for that purpose. It might be a good use for it. But we'll come back to that if we feel like it, and for the moment we'll just say we can make pixel blur calculation we can do that calculation here. If it is a camera with a long track pixel information, well, I guess you need to talk about exposure times if you're going to talk about pixel blur. So maybe that's just outside the scope of our little project. But if you knew the exposure time you were going to use, you could calculate your pixel blur, the degree to which your pixel gets, smudged and stretched in the direction that you're flying. But maybe that's just beyond the scope of... I mean, we could have one more parameter in our instrument definitions, and that would be a typical exposure time. So of course, you might vary your exposure time depending on your survey conditions, but if, and you may have multiple instruments, so it's maybe not convenient to specify for each instrument what exposure time you're planning to use. But what you could do is just for each instrument specify a typical exposure time in milliseconds, and then we could use that to do a pixel blur calculation. And if there's interest in this program, maybe I'll do that. Otherwise, maybe it's just beyond our scope. But coming back to where we were, So we won't give him information about the pixel blur. We will just make our little report. Where were we anyway? So desired pixel resolution, a long track and a cross track. So I guess the last thing to say is terrain, elevation at which to achieve desired resolution. If over the min terrain, then we say min terrain otherwise max terrain elevation and really we have our flying height. There's maybe some other information we should report, which is the flying height above the min terrain and max terrain. We did actually report that in the user interface, so we should report it in the report as well, which is kind of like doing one of these things. It's convert well, guess I'll just do it here, which is, as another property, we will have flying height. Well, no, because that's solved for in mode 3. So let me just say that you want to achieve this certain resolution over the min and max terrain, and we may or may not know how high above that terrain we will be flying at this point. So desired resolution is worst case. Oh well, clear enough, I guess. And then the overlap, and that should finish it. The unhandled enum is the if mode 3, desired resolution, terrain target. So we were going to use that in our report. We were going to say and paragraph of the inputs. This will be somewhat iterative, making our report look half decent, but summary And then, I suppose we are obliged to now calculate the outputs. I may make a structure that makes all of the calculations accessible. So, aerial survey mission parameters tool, calculations are output parameters? How would that be? I may pull out another object here. And then we'll need to do some calculations for each instrument, so for instrument, and not being a huge fan of constructors, but I will make a constructor that just accepts the input parameters, and from that we will calculate all of the outputs, and we may do it in a on-demand or a lazy way. So let's see. Or perhaps the way I should phrase that is we may do it in a more of a functional style way. So let's see. Well, let's make a list of our line item or we just say get list, or we calculate the list on demand. Well, anyway, for the moment we'll just say one of the things we're going to be calculating, as we mentioned, is the flying height, or in some cases the flying height is going to be provided, but in other cases we will solve for it. So we're going to abstract over that, you could say. I mean, the three main things to solve for are really the speed, height, and the line separation. Then for every instrument we provide what statistics that results in. So let's just have that. Let's solve for our flying height in meters, perhaps. Solved or input. Solved or given flying height, maybe. Oh, yeah, I'll say meters to start with. And that's equal to, if we are in mode 1 or mode 2, then we can return it directly because it was an input. Otherwise, we're in mode 3 and we need to solve for our flying height. So, how are we going to do that? So let's gather up all the information we need. It's going to vary. let's just say it's given in all cases our flying speed, but the most convenient for calculation purposes is meters per second. So that is flying speed meters per second. So let's just gather everything up. Local flying speed meters per second. We need the instrument field of view. Let's see. Instrument field of view. Let's just look at the radians, I guess. Well, we can do degrees because we're going to call a trig function that will accept what we specify. So, selected instrument, field of view, and we have that specified separately if we are a camera or a laser scanner. When really, but the calculation will be different in each case. So let's say if our instrument type if we are a laser scanner, that's when we need the speed actually. Otherwise, if it's a camera, you get the same nominal resolution, you just start having pixel blur if you're going too fast. But instrument field of view in degrees. Total across track field of view. And we need the overlap, and then we should be able to solve for so let's just also say overlap, or rather it will depend. Let's solve for it based on that we need to achieve the resolution from a single pass of the airplane. So we need the desired point spacing, and I could convert that to meters at this point. Desired resolution. Oh, I've got to take a bathroom break to tell you the truth. I'll be back. And we are back after a break. So, we were just calculating, we were gathering up the parameters we need in order to do our calculation of what flying height corresponds to what resolution the user wants. So, here we have the, let's just say it like this. This is the point spacing that the user wants for the lidar, and we'll convert that to meters. Excuse me. And we need the kilohertz of the laser scanner, so the number of points per second, rather. And so we have our flying speed, the instrument field of view. Let me go ahead and get the tangent of this. which will give us the footprint on the ground relative to the height. So, sorry. We can just calculate it all in one step. Let's say footprint on ground, ratio of footprint on ground over height above ground. Ratio of footprint on ground over footprint on ground over height above ground is going to be equal to 2 times tangent degrees instrument total field of view. So let's see how that looks. If we have our airplane with this field of view, we want the ratio of, if this is h and this is f, we said we want the ratio of f over h. And we can solve that by taking half of the angle and getting the tangent, which is this divided by this, and then if we multiply by 2, then we will exactly get the ratio of the footprint over the height. So that's what we did. 2 times the tangent of half the footprint. And we have our point spacing and the points per second of the instrument. So, I think the way to go about solving this is, if we know how many points we get per second, and we know what point spacing the user wants, then we can figure out how much area we will cover per second. So, area covered per second. I guess, let me go ahead and get not the point spacing in meters, but actually the number of points per square meter. Num points per square meter. And in fact, we can directly get that, can't we? Num points per square meter. So we have our num points per square meter, and we have the number of points per second. So we can solve for the area covered per second. Sorry, if I get something in my chest, particles in my chest, it makes me hack and cough. But anyway, the area covered per second, square meters, is just the total points per second divided by num points per square meter. We'll come back to this actually because there's something to do with overlap, but pressing on for the moment. And then if we know the total area we cover in a second, and we know the speed we go forward in a second, we can solve for, so what we're looking at here is, we know the total area that we will be covering per second if we will achieve the resolution that the user wants. But we don't know the shape of the area. You know, does it look like this, or does it look like that? We will find out just by seeing we're dealing with how much area per second is covered because we have our speed in seconds and we have our number of points in seconds. So what we'll do is we'll say how far does the airplane travel in 1 second, for example 50 meters, and then we'll solve for how long of a strip that needs to be perpendicular to the direction the airplane is flying in order to achieve the total area. So distance traveled forward in 1 second. It's really just the flying speed in meters per second, but just for clarity, I guess. So traveled a long track. Why don't I say that? And this is area across track is going to be the solved area covered per second in square meters divided by the distance traveled along the track in 1 second. So let's see if our units match. Square meters per second divided by meters times a second is going to cancel out the second and one of the meters from the square meters, so we will have meters, so that's correct. And then we can solve for what footprint that would give us, or rather we have this ratio, footprint over height. Looks like we actually need the other ratio, which is height over footprint. Let's just say solved flying height, height above ground, height above terrain equals, in meters, equals the area across track in meters divided by the ratio of footprint over ground over height above ground. Because this is the footprint, and so what's next? If we're solving for the total flying height, let's see, flying height means sea level. We have our height above terrain. Now we need to know if what is it? Input parameters. The resolution, the terrain target. In fact, I may just what can I say? Oh well, I'll do it in 2 steps. Let's just say terrain, target, terrain, elevation, meters. And if we're looking at the min terrain, then we say that it's equal to min terrain elevation. Otherwise, oops. If it's over the max terrain, then we look at the max terrain. Otherwise, sorry. So, So solved height above sea level meters equals solved height above terrain meters minus, or rather plus, target terrain elevation meters. We'll come back to this for one thing, but let's move to the camera. If we are a camera, I mean otherwise then if selected instrument it's not a camera or well, yeah, we have our cross track and our number of pixels across track, our field of view across track and number of pixels across track. Let's just say if we're not a camera, then that's an assertion failure. Sort of an unhandily name. So let's just get these across track, total field of view, and pixels across track. Logically an integer, but for our calculation purposes it doesn't matter. We can consider it a real, basically. And so we just want to solve for the height above ground, and it should be pretty straightforward. We again want the footprint, so ratio of footprint on ground over height above ground. And let's see. Target pixel size across track centimeters equals let's say target pixel size across track in meters equals that in centimeters divided by 100. And then let's get the total footprint, given that we know how many pixels we have and the footprint that we want per pixel. So that would roughly be correct, I suppose. Let's just say total footprint size across track equals, you know, it may not be perfectly accurate because pixels that are not pointing straight down off nadir pixels will have a slightly bigger footprint. But basically we just would be anyway, it's It's works out to be probably on average or something correct. So let's see. Total footprint size across track is target pixel size for each pixel in meters times the number of pixels. Pixels across track. So with the footprint size solved, we can solve for the height above ground. So solved height above terrain in meters. What should we do? Some of this is copied. I guess I'll leave it as two cases rather than put the solved height above terrain outside, because I think it's simpler. Let's see. Is going to be the total footprint divided by that ratio. And then, similar thing. Yeah. A similar thing where we get the target train. Maybe this is what I should pull up. Target train elevation in meters. So we solved our height above terrain, we get our height above sea level, and we return our height above sea level. Looks like we had an error here. So that should be right. Cross-track field of view, num pixels. Here's this ratio. Then our target pixel size on the ground. Total footprint size. Then we solve for the height above terrain. And use that to solve for the height above sea level. And return it. So the one thing we should come back to here is the, let's call this effective num points per second. If we allow overlap to count towards possibly increasing the number of points per square meter, then we'll do an adjustment here. So if laser scanner, if we are in the mode that you may consider overlap, then let's get the overlap factor. Let's say if laser scanner well, where are we gonna put this? We have the overlap. We have the overlap fraction. And if greater than 0.5, num points multiplication factor is 2. If greater than 0.66, num points multiplication factor is 3. So what is this if this is greater than 1/2? This is greater than 1/3. So I guess all we do is take the reciprocal, or rather, sorry, the reciprocal of the inverse, or the complement part of the fraction. So this is going to be this is reciprocal complement contribution. Contribution. Strip contribution. Lateral contribution fraction equals 1.0 minus the overlap. That means we also need to test that the overlap is not greater than 100%. So when we go to our main form and we parse out the overlap, we need to make sure so right, the overlap can be negative. That's okay. The user might be specifying it that way for some reason, but if the desired overlap in percent is greater than or equal to 100, then we have to say error overlap cannot be greater than 100%. Cannot be greater than or equal to, but I guess they'll infer the problem there. Or equal to, okay. So I'm going to call 1 minus the overlap as the lateral contribution factor, because if you have 66% overlap, then the next strip is going to be coming here, and here's strip number 2, and it is contributing about 1/3, and the overlap is 2/3. So the lateral contribution is maybe 1 minus the overlap. So then we get the reciprocal of that. Reciprocal then we convert to int, and that is in fact our effective bonus to the number of points. I'm calculating it as a bonus to the number of points per second, but it's equivalently a bonus to the number of points per square meter. Well, anyway, I have a feeling we'll need this again when we output the report. Let's see, I don't know if we will or not, but I want to not necessarily have the logic for this calculation here. I want to maybe put it let's see about having as as a property here. If laser scanner effective num points per second after multiplying by overlap bonus, if any, and if user, and as user specifies. So come to our logic here. Actually, all of this. I don't actually think we'll need it any other place than where we had it, but oh well. So if the mode is that we can consider overlap when achieving the desired resolution, then guess I'll just say let's see. Basically like that. So here I'll say we'll just do that. I don't know. Maybe I should have left the low logic here, but yep. So we have solved for the flying height in the case that we are in mode 3. So we also need to solve for the strip separation. Given, solved or given strip separation in meters, let's say, or the flight line separation. Flight line separation. And if we are in mode 1, we can return it directly. Otherwise, we need to get the height and the overlap. So actually another useful parameter to have is solved or given flying height above terrain, in fact. Flying height above target terrain. And that's, I'll just call that solved. And oh, what do I want to do here? Well, the solved for given flying height is, if it were actually given, we return that. And if if otherwise, we should be in mode 3, and we will return it's just solved height above terrain. And return terrain elevation. I guess I should just have, I should really go ahead and make this a property that just says target terrain elevation meters. So let me do it. Where is this gonna go? It might be right. It can go here. We know the min terrain and the max terrain, and if mode 3, I guess. If mode 3. If mode 3 target terrain elevation meters. So a little bit of a functional programming style. Let's see. Right. Let's just say just want it to look a little better. Otherwise it was just an input. So coming back here to our, when we solve for the height above terrain, I guess we can write this function. It's depending on what mode we're in, it will be calculated differently, and I needed it for mode 3 and mode 2, but I will make it valid even if we are in mode 1. So let's just say well, no, it really only works if we are in mode 2 or 3. Otherwise we don't know what the target terrain is. Actually, it only works in mode 3. I have to think about this. Did we not fully specify our user interface? That is kind of annoying. I think I have omitted one thing from mode 2, and that is, if you want this much overlap, you need to specify you want that much overlap over the minimum terrain or the maximum terrain. So we need to do some rework here. So I want to get the project to just compile. We will sort of abort where we are, and we need to let me just fix my compilation errors wherever they may be. This is a constant now in our units and conversions function. Again. So let me copy that this time. Let's see. Generate report wants a return value. This wants a value. Flying height above terrain. That's the function we're writing, right? So we could just insert that here, right? Flying height above target terrain. So now do we compile? So this is going to be a little annoying, but we need to do some rework. So I'm just going to save my source code before I do it. Notice the prompting of going to the designer prompts me to do this. Let's see. B or so. So we have it here. Maybe we'll just desired overlap. Get rid of that comment, I guess. And just say overlap over min terrain or overlap over max terrain. So we could still say at worst, but at worst would be over the high terrain. So we should say at minimum, maybe. Well, let's get our radio buttons. Let's see. So user interface wise, it isn't too bad to add this in. Guess we'll just get rid of this comment. I just wanted it to convey that the desired overlap here applies to this instrument. But I guess this is enough of a tip about that. So what's our naming convention for radio buttons? I'll just check here. We said RB mode 3, and then whatever. So this is RB mode 2. Desired overlap is over highest terrain. And then here, RB mode 2, desired overlap is over lowest terrain. And these can have the value saved that the user last entered. Why is it asking me about data binding? Did I have another thing selected? Let's say that this is the default. Then, where all do we need to reference that? I guess the rework isn't too extensive here. It's just a enumeration in the input parameters. So if we have an overlap, so we just have an if mode 2. Guess I can keep my enums together. Let's just say if mode 2 overlap mode enum, overlap specification enum, specified overlap is over minimum terrain, or specified overlap is over maximum terrain. So we just say if mode 2 look at my user interface again. Otherwise, we are specifying it in terms of resolution. So possibly there's a redundancy, or we could consolidate these, but I think it's more clear to keep it separate. So if mode 2 overlap specification mode, I guess, or option. Let's see. Then when we produce one of these input parameters object from the main form, we will need to set that. So down here in our produce input parameters, or return error to be shown to user. well, I don't really like this name. Produce input parameters. If result is error, then message box user. I don't know. If result is error, then should message box. Then should message box user. I guess. But let's see. If we are in mode 2, then when we come to the overlap, oh, did I add this test for both cases? Because also if it's mode 3, there we are. But anyway, one more check. If this radio button mode 2 desired overlap is over the highest terrain, one of the reasons it's more clear to keep these separate is the defaults are probably different. The default value here in node 2 is that the overlap would be achieved over the highest terrain, but in mode 3 the default would be that the desired resolution is achieved over the lowest terrain. But let's see if that then over the highest, over the maximum, also if over the lowest, then over the minimum, else please specify whether overlap applies to if the user has entered the same value for min and max terrain because he just doesn't care about that, then maybe we could not force him to specify, but oh well. So back to where we were. We were coming along here to our calculations, and we were solving for height above terrain. So we given flying speed, solve for given flight separation. We'll need to come back to this. If mode 2 or 3, we're solving for the height above the terrain, of the target terrain. So if we are in mode what do we say here? What do we say here? Let me just go look at this one. Solve for given flying height means sea level. Alright, this can be expressed relative to height above terrain for either mode 2 or 3. Or no, if it's mode 2 you get this directly, or mode 1. If it's mode 3 you get it relative to the terrain. But either way, we need to solve for this. But if it's mode 2 it's real easy, so right, if I guess what I'm trying to say here is I want to have solved height above target terrain. Solved solved target terrain elevation is what I'm getting at, rather. If mode 2 or 3 solved target terrain elevation. This is what I want so that I can use it in this function. So, if input mode don't call the property. So if it's mode 2, our target terrain elevation is were we adding this into, I guess we were adding this into, just getting a little lost, but coming back, lost and confused. Coming back to here, we were adding this into here, weren't we? Let's see. Here we have it if it's mode 3. We can write this as if mode 2 or 3 target terrain elevation meters. If mode 2 or 3 target terrain elevation meters. So if this mode is mode 3, goodness, what did I copy anyway? Why don't I just take this so if we're mode 2, do mode 2 here. If we're mode 3, do mode 3 here. So if we're in mode 2 and our overlap is over the maximum terrain, then we can return the maximum terrain elevation. Otherwise, over the target is over the minimum terrain, return this minimum terrain elevation, and otherwise error, assertion, failure, unhandled. So there we are. If mode 2 or 3, our target terrain elevation in meters. Back to where we're doing some of our calculations. So here, if we just want to solve for our flying height above the terrain, target terrain elevation equals see, well, is that it? Flying height above the terrain. We want to solve for it, and here we have our height above terrain. This is what we want to return because we've renamed this function. Sorry for this, it's a bit scattered, but anyway, we thought it would be useful because we're going to solve for the flight line separation, which may deal with overlap. So we need to know our flying height above the terrain. We had previously calculated our flying height above sea level, but as part of that we had calculated our flying height above the terrain. So now we're just reworking that. So we'll directly have this to access our flying height above the terrain, and flying height above sea level is calculating correctly because it's just, you get the height above the terrain elevation, if mode 2 or 3. Guess I should make my naming convention consistent and use a lowercase or here. Then, so here in this property that says flying height above target terrain, we shouldn't see anything about sea level. What we should do is just say that here is, why do I even need this here? I don't need the target terrain elevation. I'm solving only for the height above the target terrain. So that's going to be solved height above the terrain in meters. Otherwise, in the camera case, solved height above the terrain. So that's finally somewhat organized. We have our flying height above sea level, our flying height above target terrain. So no matter which way the user has input things, we can just access it in the way we need to solve it on demand. And now the flight line separation. So if we're in mode 1, the user just provides that. Otherwise, if we are in mode 2 or 3, we just need to know the target terrain. Well, rather, yeah, we'll know the overlap. Either in mode 2 or 3, we know the overlap. We know the height above the terrain, and that will give us the separation. Or the distance from one flight strip to the next. So, flying height above terrain equals, I could say effective then need to get the overlap. Let's see, from the field of view. If mode 2 or 3, selected instrument, field of view. It is actually useful to just have an instrument total field of view. So this is something we debated way back when, whether to have this and this or have just one. And I guess at this point we'll just go ahead and do this. If it's a laser scanner, if it's a frame camera or push broom camera. Sorry, this should see degrees. Otherwise, double local instrument field of view in degrees equals clear my throat for a moment. So if we know our height above the terrain and we know the field of view of the instrument, then we know the footprint on the terrain, then we know the overlap that the user wants with that instrument, and that will help us solve the separation from one flight line to the next, which is just kind of the complement of the overlap. So let's do it. Let's get the footprint. Strip width, i.e. footprint on ground, equals 2 times the tangent of our instrument field of view times our height, this over 2 rather, instrument total field of view. So this gives us the ratio of footprint over height. Then we multiply by our height, and we get the footprint. Then overlap fraction equals the overlap fraction is this. So strip contribution fraction equals 1 minus the overlap fraction. We talked about that a little before. Lateral So our flight line separation is just the lateral contribution factor times the strip width. So now we're in a position that no matter what the user provided as the inputs, we can get the speed, we can get the separation from one flight line to the next, and we can get the total flying height above sea level. And with those three parameters, we can then go and solve for each instrument. We can solve for each instrument the resolution and so forth that is achieved. So let's do some of that. Let's just say we have a parent and we have a object instrument. And let's do some of the calculations, which, for example, so it's a lot of forward and reverse solving in a sense, but what we want to output is strip overlap. Well, overlap at highest train, overlap at minimum train. So let's say you know, this is the across track overlap fraction at min terrain. Well, that would be height above the terrain, height above min terrain, I guess. Let me add a couple more things here. Solved flying height above min terrain meters, which is going to be the solved flying height above sea level minus the min terrain elevation in meters. We'll have another, which is the solved flying height above the max terrain in meters, which is similar. So, height equals solved flying height above the minimum terrain. Because, you know, the user might have specified the overlap for one instrument, but then we want to output the overlap he achieves for each instrument. So we're just going to solve it for each instrument, even if it had been one of the inputs for one of the instruments. So we get the height above the terrain, we get the field of view of this instrument, then we get the footprint, so strip width, a footprint in meters is equal to 2 times instrument total field of view, half the field of view, take the tangent, multiply by 2, then multiply by the height, That will give us the strip width, which is itself a useful parameter. So let me just calculate the strip width. And we're going to have it like that. So then to calculate the overlap fraction, we also need the flight line separation. Then if our strip width on the ground, our footprint on the ground is this big, and the separation from one line to the next is, you know, this big, then the amount of overlap is, you know, kind of the complement of that. So the strip width minus this, the flight line separation, will give you the footprint of overlap. And if you divide the footprint of overlap over the total footprint, you will get the overlap fraction. So let's say let's see, overlap, footprint overlap equals the local strip width minus the flight line separation, which could be negative, right? If our separation is from there to there, but our footprint is only this big, then we will take the strip width minus the separation, and we will get a negative value for all of this. So that could be negative, but then as a overlap fraction, it's just in meters divided by the strip width in meters. So I will return that. That's at the minimum terrain. We have it again at the max terrain. I guess the strip width depends on the min or max terrain. Strip width, i.e. footprint, over min terrain. And again, over max terrain. So here, our overlap at the minimum terrain uses the width at the minimum terrain. Our overlap at the max terrain uses the strip width at the max terrain. And what else would we like to calculate? Strip width, overlap. If it's lidar, we want to know the resolution. If lidar point spacing, for example, in centimeters. And we need, flying height. Oh, at min terrain over minimum terrain. So flying height equals flying height over the min terrain. And the footprint. Strip width equals this, strip width over the min terrain. And along track distance covered in 1 second equals flying speed in meters per second. So now we have the area covered, the strip width in meters, long tracks distance covered by the airplane in 1 second in meters, then area covered per second in meters equals the strip width times the long track distance. Let's put this at top. These are all gonna be, this one also. So that when we do the maximum terrain version, we just modify these. Area covered per second in meters. So, num points per meter. Guess we'll change this to num points per square meter, as we solve for that more directly. Equals from a single pass. Sometimes in English, if I want to say from a single pass, but then that makes my capitalization, my camel case capitalizing, makes these two words run together. So I use an instead of a, which is a semi-legitimate thing to do if you look at the etymology of the word an. Anyway, Wiktionary.org wiki. Or rather, oh, just curious, sorry, quick detour in English, etymology. Well, let's look at an etymology. In English, oh well. I thought that an was etymologically that a derived from an, but anyway. Num points per square, yeah, from a single pass. So now I take the number of points per second from the instrument and number of points per second divided by the area would give the number of points per square meter. Let's see. Square meters. So if I have 100 points per second and I cover 10 meters in a second, then that's 10 points per square meter. So let's divide that way. And that gives us the num points per square meter. Another thing to solve for here is the resolution over the maximum terrain. Which is just taking this and this. Notice how it comes in from two sides. Let me just see. There and also... Oh, we're not using the flying height. We're not using the flying height. It comes into the strip width. So, we don't need that, and we don't need that. After considering overlap, so I guess we will use this again. It's just the parent if laser scanner. Maybe I should refer to the inputs again or directly. This might be useful. That might be useful. So if we say input parameters, effective num points per second after multiplying by any overlap, if any, and as user specifies. So that's and the overlap is also going to depend on the terrain. So never mind for a moment. We need to do some calculating. So if we are lidar and we want to know how many points we get on the ground after considering overlap, if we're looking at over the minimum terrain, we have to calculate what's our overlap over the minimum terrain and recalculate the bonus as to how many times we cover it. So let's do it. If, or rather, overlap fraction equals the cross-track overlap fraction at the minimum terrain. What I may do is have a little utility, little helper function. Where can I put it? Where would I put this? Here where I'm doing this calculation, I want a little utility for it. And maybe it could go under the units. Why not? utility function, let's see. Get num times covered. Get num times covered. Get minimum num times covered. For given overlap fraction. Minimum times ground covered. For the given overlap fraction. And the logic for this is sum of this. This is going to be the overlap is coming from where? Coverage multiples. So if it's a laser scanner, I don't know. I probably should not have made this property, but that's okay. Coming back over to here. And that. That's what it is. Let's see. And coverage, multiplication factor. Num times covered equals so then effective num points per second equals just one way of incorporating the multiple coverage into the calculation. I guess maybe it's num points per square meter. You know, why am I doing this? Why don't I say it's this, num points per square meter from a single pass, and just say that's what I wanted, isn't it? I lost something, didn't I? Hello? And down here, it's gonna be from the max. So, we're calculating a number of parameters here. Take a short pause, and we're back. So what else do we want to calculate here? For each instrument, we want the strip width over min and max terrain. We want the overlap fraction over min and max terrain. We're calculating the resolution we get if we are lidar. Let's calculate the resolution we get if we are a camera. If camera, across track, pixel, resolution in centimeters. Probably going to technically calculate this as the nadir pixel. So, over minimum terrain. Over minimum terrain. So we need our flying height over minimum terrain in meters, and that's from our parent. We need the in the input parameters we have, if we are a camera, for the instrument rather, for the instrument, if we are a camera, we have the nadir pixel field of view. How should I do this though? I could take the total strip footprint and divide it. I mean, that would be the average resolution, and that's probably better. Let's just say average pixel resolution. So we need the strip width. Strip width in meters over the min terrain. We need the num pixels equals from the instrument. Then we just take, heck, I guess this is all we need, just two parameters, isn't it? The strip width and the number of pixels, and we say so if I have 100 meters and 1,000 pixels, I'm gonna get 10 centimeters per pixel. And that's in meters. Pixel resolution in meters. So we'll do that similarly over the maximum terrain. So we have our resolution in the across track direction. Now let's say if camera with across track pixel info along track. Along track. Let's again do, I guess, average pixel resolution over minimum terrain. Let's do one more thing, which is we have our strip width. But let's say if camera, then it's also interesting the footprint along track direction. So if camera footprint of a long track field of view. Over min terrain, over min terrain. if camera with a long track pixel info. Footprint of a long track field of view over min terrain. So if the instrument is a frame camera, well, anyway, field of view, let me just say instrument along track field of view degrees. Maybe this should just go into the instrument configuration properties itself. If camera with a long track pixel info, a long track field of view. So if instrument type is a frame camera, if this instrument type is a push broom camera, otherwise, shouldn't call be nice if there were a way in reflection to get the name of the current function or property, but I'm not sure. Actually, is there a quick way? .NET reflection current function, yeah, method name. Well, no, it should work fine. In fact, I've done that before. Stack frame. Anyway. I can save that. Come over here. And get the footprint on the ground of that, which is going to be the height above the min terrain. So that's why we are writing this program. Hopefully it's helpful. Let's see. V 2 times total field of view divided by 2. This is ratio of footprint over height, multiply by height. We get the footprint. That's what we wanted. Sometimes I'm not returning this value directly, just because we may have occasion to step through in the debugger, and it's nice to just set the breakpoint here and see what the value has been calculated out as. So that's the reason for that. It's also just a little more literate. Newth's literate code, just saying that it's describing itself a little more. So let's see. A long track footprint above the max terrain, if we are a camera, is just that. So coming back to our resolution, a long track. So footprint along track equals a long track footprint over min terrain. Try to always remember to specify units. And if mode, if the instrument is a frame camera, then we can divide by the number of pixels, take the footprint, divide by the number of pixels. The long track direction. If we are a frame camera, push frame camera, then we don't divide, we only have 1 pixel. Otherwise, unexpected instrument type, then that's what we return, just so there we are. And one more. It's over the min terrain. Here we have it over the max terrain. So what else are we going to want to report? We solved for the speed, the height above everything, the flight line separation. We solved for the overlap you're going to get and the resolution you're going to get. So I guess that's just about it. So this just needs a way to get, why don't I just do it this way, num instruments and we'll have get output parameters or statistics, get output parameters and statistics for given instrument by index, 0 indexed. This is a way I have of specifying that the index starts from 0. should I say it more explicitly? Instrument index. So now we just return a new that accepts a parent and a particular instrument. And down here, this with the input parameters, configuration list, number, that one. So we should be able to write a report with that information that we've written up. So stretch my legs for one moment. And we're back. So we are thinking about writing a report. So we input the input. We output to the report the input parameters. And maybe we go through and add all of the Oh, I wonder if we have something like add field and value. So let's see. From the input parameters, so let's just say our flying height above min terrain guess I will omit the colon, so I'll say without colon. Flying height above min terrain is meters and feet, and go bother. I mean, it should already be somewhat well-rounded because the terrain would have been, well, no, the meters might not be rounded at all. So I want to round it to something. So a little more work here. Let's go in and add convenience strings and unit rounding. This is a given. flying height above min terrain, meters, and etc. I need the string for this in meters and feet. Flying height above min terrain in meters as a string, and this as a string. And maybe I'll put all of these down below. We will also have the same thing in feet. So, and instead of double, it's string. We'll return this, but this function, if we remember it, round this value to the number of digits we had in the original input on the, for example, height. Let's add one more thing, or let's just say num digits on height. Well, actually, it's kind of a three-way minimum here. Let's say num significant digits for height. And this is the input this is the canonical form in feet, so we'll get it from this. And let's just return a maximum of num digits here, or there, or let's just say 3 as another minimum. And then if the user specified a height, one or two, then we subject it to a third minimum, or a third floor. So we take the max, flying height. So how's that? It's just what I do. So now to string given number of significant digits, which is the num digits for height. And again, but now it's the flying height of the max terrain with the same number of digits. Then feet. Let's just do the conversion in here. Times meters per foot is the conversion we have, so we'll divide by it. And a similar thing goes here, so this is the min, and this is the max. So as we write our report, we have flying height above the minimum terrain. I guess the flying height itself is, so flying height above sea level. So let's do that. It's another string. Flying height above sea level. I want meters and feet. Maybe I should structure this a little different. In terrain, meters and feet. Max terrain, meters and feet. Height above sea level. So solved or given flying height above sea level. Solved or given flying height above sea level times the conversion factor. Flying height above sea level. Might be. Why don't I change my convention here and just say string? This will be nicer if I put the string as a prefix. So let me get rid of all my suffix strings. And where I had said solved as a prefix, it's now string as a prefix. But I applied that too rigorously, so solved. 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 Does that look right? Flying height above sea level. Alright. String, flying height above sea level. This many feet. This many meters. Flying height above min terrain. Feet. Meters. Flying height above max terrain. max train, max train. I wish, by the way, that Visual Studio had more options for matching case. So I want to match case in the way that I do the replace, but I want to do it for both the lowercase and uppercase. It's like, you know, min to max. Basically, I could do both min to max and min to max in one step in the find and replace dialog. And I think they could implement it, but they don't. Let's see. What else are we going to output? Well, let's just see what we've calculated so far. What are the things that apply to the entire airplane? We have, gosh, go down, 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 down. I mean, I guess we can repeat it one more time. It's kind of repeating ourselves, but let's say flying speed, which is going to be okay. Flying speed. Might be a little confusing there, but so flying speed, height above min and max train, flight line separation. There's a good one. And let's have num-significant digits for distances. And if we are in mode 1, where the user provides the line separation, we will subject ourselves to one more maximum. Num-significant distance for distances, and then we have some strings here, public string, flight line separation in meters, and then we have flight line separation in kilometers. No? Yeah, I don't care about solved or given anymore. Don't care about that. And what else? Speed, heights, flight line separation. I guess that's everything that applies to the entire, everything that is not instrument specific. So then let's, for each instrument, and let's just say maybe add separator. And add maybe a header of the instrument. And then go through and add some fields. So what kind of fields are we going to have? Maybe resolution is a thing we like to see. Well, let's see. We've got resolution, overlap, and footprint. And what order should we specify those? Maybe resolution, footprint, and then overlap. Maybe overlapped first. Maybe overlapped footprint resolution. Anyway, overlap. Let me go ahead and add some helper strings. What is this? Yeah, I closed that one. Let's see. String cross track overlap percent, it will be at minimum train elevation. And let's say num significant digits for percentages. Let's just say 3. And so at minimum train elevation, minimum overlap fraction becomes a percentage by multiplying by 100. Minimum is maximum. Gonna need all the other stuff, aren't I? strip width. Maybe I should do it in the order they appear. Strip width, I footprint over min terrain, meters. Let's just say strip width over min terrain, meters. And this is going to be rounding to the number of digits that we used in the parent, significant digits for distances. How's that? And strip width over max terrain. Convert to string, strip width over max terrain. Footprint along track. If camera with a long track pixel info, footprint of a long track field of view over min terrain. Well, that's what it is. I must say. And over max, over max. Cross-track overlap fraction, we did that. So now this one. And num points, num significant digits for resolution. So what can we say here? What can we say? And I think by default we'll have 3, but if the user has specified a resolution value, so if we're mode 2, it's only mode 3 that he might be specifying a resolution or point spacing. So if the type, mode, input mode type, if we are in mode 3, then if private input parameters, if mode 2 or 3, if the instrument type is a laser scanner, well, no, either way, it's just whatever the user put in that field, which is coming from the value, which is this big long name. Because the user, the way we have this working, the user might specify something here, but the number of significant digits he used here is related to the number of digits we show here. And so then we take the number of digits here to know how many number of digits we should have when we talk about resolutions. Max of itself and this other thing, which is yes, 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 yes. Let's go see what's next. If we are converting something to a string that is a resolution, we will refer to the parent num significant digits for resolution values, and this value is if lidar num points per square meter from a single pass. We'll have another string which is point spacing centimeters, which is our conversion util. Num points per square meter to lidar distances. Right. Then we have over max terrain. Sounds about right. Point spacing, point spacing. Then we have, after considering overlap, lidar over min terrain after overlap. It's really the minimum num points after considering overlap. But similar to this A, let's just see. We've got this with this function, property name, and that was over minimum, here's over maximum. And another string representation which is point spacing centimeters. For which we take we convert this value to no, it's already taking it. Just going a bit buggy-eyed here. Let's see. From single pass, let's see. From a single pass, min max. Okay. Right. Min max. Points per square meter and point spacing. So anyhow, lidar, this should be the same as that, but we convert it to lidar point spacing from points per square meter. And I don't know, maybe that looked better like that. Then again, the thing to do is take these together. Min becomes max. And I think that's okay. So lidar then we have some cameras. So let me just gather up our names. We've got this guy and this guy and this guy and this guy. Oh. Footprints. Overlaps. Cameras. So starting with this. We have that and min and max, so then the next thing sure it's gonna be similar. It's just this goes here, and it's min and max. Whoops. Rather, this goes there. Min and max. There's all of our strings. So we go back to our report, and we say that comes first, huh? So overlap over min terrain, I guess. Overlap over min terrain. That's a cross track. Overlap across track. Guess I'll spell it out. Overlap across track over max terrain. And if it's a camera, and here we have overlap along, well, it's rather footprint, I guess. So hold off on that, I guess. Footprint across track over min terrain. Then, if we have the information, cross track, along track, footprint along track over min terrain. So let's see. What's next? That was, we've got overlap and footprint, and now resolution. So, if we are a laser scanner, resolution over min terrain, and that's going to be okay, right, string. We've got a bunch of string if lidar, num points over min terrain. Oh yeah, from a single pass. Resolution over min terrain from a single pass. Resolution over min terrain from a single pass. Points per square meter. Over minimum terrain. max terrain. And max. Then we'll have resolution over min terrain after considering overlap. After considering overlap. After considering overlap. And then min becomes max. So some long lines here, but that's what I end up with. Programming as I do with a lot of very explicitly named properties and variables. Alright, otherwise it should be a camera. Resolution, a cross track. Cross track pixel resolution over minimum terrain. Centimeters per pixel. Resolution across track over max terrain. I just feel like having a random look at how we calculated this. For max terrain, strip width over max terrain, num pixels. Alright, so if we go down on the strip width, and so forth, well, it ought to all work out. So back to where we were. If then go ahead across becomes along. If camera with a long track pixel information, a long track over minimum terrain, and this is over max terrain. What else? What else do we have? So we've got overlap, footprint, and resolution. I guess that does it. So we come here to our loop and we increment. Here we have a separator. Should we run our program and see if we get anything but plain text report. So all of these are just pretty much append line for the plain text case. Okay, append line, yes. Add paragraph, add everything from the paragraph. Possibly just append, but we'll see how it looks. In this case, we say arg field name, maybe just this. If it's a separator, we just do that. Get plain text report. So we need a window to show our report. Guess I can put it here. Sort of feel like it doesn't really belong there, but oh well. I'll put it here. Report window. The nice long name. Extend our custom control WinForm space out of habit. Change our namespace. Go to the designer. So I think what we'll have, guess I'll try to see if I can get away with increasing my font size just a little. I think what we will have is another tab panel. And we'll say I'm not certain how this is going to work out in the end yet, but we just need a way to save. Close. Close and what else? Save. Where should I put my save buttons? Maybe here or down at the bottom. I guess on the side. Save. And some anchors. This will fill up the entire tab page, so I can, let's use simple anchoring. This will anchor everywhere. This will anchor on the bottom. This will anchor on the right. This will anchor everywhere. This is called maybe we can have the report be assigned to this on construction. Then when the form is shown, we say that the text of our report is equal to our report, get plain text. Nothing else really. So when we click the calculate button, hurrah, hurrah. If there's an error, there's an error. Otherwise, new report from the input parameters. This is a structure with the first being a result, the second being well-formed input parameters if they were well-formed. What is this? Output. Which takes an input parameters. Then we make a report. From this, we get the report. Output, calculation workspace. From the calculation workspace, we get our report. Did I not make it public? Generate report. It's just from here. Oh, report util. Somewhat less impressive than this otherwise might have been. From the input parameters, we generate our report. And then we have a window that takes the report, and we show the window with ourselves as the parent. So what are the chances, eh? What are the chances that we get a result on the first run versus an entirely possible exception on the first run? But let's see. Minimum terrain, let's say 1,000 feet to 1,200 feet. Let's say we're flying 100 knots. What the heck is that? Oh, I see. Well, I meant to be in mode 1. Now see, why can I reproduce that? I thought I was in mode 1, and yet I was in mode 3. Oh, okay, it's not working. So this is great. Let's see why it's not refreshing. So I should have check changed handlers. Oh, stupid sender stuff. Where's my radio buttons? Where are my radio button handlers? These guys. Why are they not being called? Okay, he gets called. I set the selected index to 1. Okay, we're at 1. We're at, well, 0 is mode 1. That's mode 3. What the heck is going on when it doesn't work? Okay, it's changing the mode, It's changing the tab, but it's not changing what we see. Because I need to invalidate it, perhaps? That would be pretty much retarded. This would be retarded if this is what I have to do, but... because I'm doing it without an event, maybe the base class is what redraws it. I mean, the base implementation of the function that corresponds to that event. I mean, in general, I'm gonna want it to redraw, so... that was a little more than was necessary. But here we are. Maybe an invalidate? See, it's open in a way that it doesn't realize what file it is due to some symbolic links I have in my source tree and the way that I found the files to bring this up. But if I just invalidate, or perhaps I should put it here. Found that apparently not calling base on selected index changed function prevented from being displayed properly, from tab switch from being displayed properly. Rebuild that. Yeah, I did reload it. Okay, so let's get my IntelliSense. I don't know why that's a problem. I typed it wrong. And off we go to see if that problem still exists. Which we should never see. Ah, it's still happening. That is so annoying and really so stupid. I'm switching the tab, but it isn't updating what I see. Which is just really quite retarded. Here I am getting detoured and sidetracked about this, but honestly, I set the selected tab. Why doesn't it refresh itself? Or draw itself? What the heck? Who the heck knows? Do whatever you need to do, Control. Come on. Or maybe I need to invalidate the children? Let's say that the selected tab is invalidated. Will that do it? No, it doesn't. Wasn't this working before? Why is it not working now? That makes no sense. I mean, could it be something that we did? All we did is, for example, in refresh form, when we synchronize stuff, this should never happen. This code is not relevant. Okay, it did happen. It's... yeah. Even so... even so... I mean, this is one of the things we added in this session. But we added this because we saw the problem, didn't we? And it makes no sense because I remember this was working. So why does it now not like me anymore? Should I just step through this? Yet, it is going to work if we step through the debugger. See, because the window gets redrawn. What? Should I invalidate the parent window? Retarded. I'm not sure that me trying to invalidate my parent implies that I know what I'm doing. It might imply that I don't know what I'm doing, but let's fiddle with stuff. Hello, hello, hello. No. What is that perform layout? What about that? I mean, surely I am calling the place where I'm making these adjustments. Oh, invalidate and all this. Load the file, come on. So that means I need to set a breakpoint, for example, there. Step inside. It did not step inside. Why? Why didn't you step inside? If I look at my modules, apparently I don't have symbols loaded for that, so if I look at my modules and I find custom control and it says cannot find or open the PDB file, I think Visual Studio just wants a restart. We'll close that. We'll rebuild this. Hello, hello. Maybe we'll close that as well. This does not need to be running. Why is it? So we open back our project. And we see if we will step inside. Right. Doing all this stuff. I just can't believe it. It's pretty much retarded. That this doesn't work. I mean, just because I'm not generating the base class call. And yet, how else do they expect us to hide the event from being generated? What was that? Well, see, this is why I implement my own parallel implementation of event handling. Just confirm that this solves the problem, I guess. C tab panel. Always call the base class. What do we get now? Hey, look at that. It works. Amazing. Oh, this is retarded. So what? I need to find everywhere I have a selected index changed handler for a C tab panel that doesn't use my custom handler. What am I using in my code? See, I'm using the regular handler, but if I want to be able to call the function without generating the event, I mean, it's just a simple thing you should be able to do. I mean, maybe I don't even necessarily need it for what I'm doing with this particular form, but it's really a fundamental thing you need to be able to do, is to set something programmatically without raising the event handlers that you specify that you write for when the user does something. Those are just different cases. So instead of letting the really? Nothing is there? That is surprising to me, but this tab panel, delegate, selected index changed, add handler, our own, what is it even called? Tab panel, calculation mode, selected index changed, but this is going to be renamed as well. Handler, because that's how I name my handlers. And it's just better anyway. So, you stupid thing. don't need that anymore, but because I have made a change to my code base, it's retarded. Let's sign that twice. Don't need any of this. What I need to do is find everywhere in my code base that I am using a selected index changed handler on a CTab panel. But how am I even going to do that? I guess search for what the designer would generate. Plus equals on selected index changed. And see if it's referring to a tab panel. If I go back to my designer, if I undo what I just did, oh yeah. Selected index changed plus equals. It's what it looks like if you let it happen. So I've got one there, and they're all tab panels. And honestly, I'll deal with this later. I just want to say revise. 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 I mean, I don't know if in any of these cases I care about handling the version. I mean, I don't know if I care in any of these cases about generating about changing the tab without generating the selected index changed event, but I will review them and deal with them later. Retarded. Right, well, here's two that I have to deal with now. So this, instead of registering for that, instead of this, we have this. And we add it in our own control initialization. It's odd that I don't know what list view it was referring to. Tab panel files listing. Right. Don't know why that's a problem. Well, goodbye to that. Why is it? Really didn't like something that I did here. Maybe I should have gone and, but this is the list view. This is the event handler. idea what this old program does, but this event handler we now call ourselves. How's that? Why don't you like it? Man, just what is your problem? Oh. Removed too much. Maybe that's what I did in the other case. My goodness, my goodness, my goodness, my goodness. Ah, there we are. So I made a similar mistake in both cases. Well, after finally dealing with all of that, let's see our little program, retarded as we complain about it being. One more thing I'm going to do, which is I don't need you open anymore. I don't need you. Back to our refresh form function. Well, I'll leave it. I was going to enable that again, but I don't want to until we are initialized. On load, we call refresh form. If base initialized is true. I can't remember if this property works correctly. It's happening, and it's happening. From here, which it shouldn't, because the initialization should be false at that point. So, oh, no, we're okay. We are okay, it did not happen. So it's here that I want to test for, and that doesn't happen. Alright, well, after all of that, long detour from the exciting thing we were about to do. If you remember what we were about to do, we were going to generate our report. So from this tab, I have this speed, I want this height above the ground, I want this much separation between my flight lines, and let's just see. Kaboom, kaboom, kaboom. Alright, Stack Overflow on that guy. Someone had a creative idea to name a website for that, didn't they? Meters. Was it this one? Which one is referencing itself? Oh, I should have taken a moment because this was evidently not the problem. That wasn't the problem. Well, who is the problem? 100 knots, 5,000 feet, 500 meter strip separation, flight line separation. No. So let's see. Come on, let me break. Let me break before you overflow. Just let me break. Yes, yes, yes. It'd be helpful if this did not return itself. Returning the overlap might be helpful. Which means this one has the same deal. Why don't we just try that again? Wow. Hey, we got a report. Let's see it. I've got to go fix that. Why did my window not resize? Let's fix my window. It's anchored everywhere. Of course, the tab page itself doesn't need anchoring. Well, let's see. Let's look at our report and see if there are any ridiculous things in it. Here are our instruments. So we fly at this value, rather. Okay. I really should put this down below. Then, here comes the report. Flying speed is 100 knots, etc. Flying height above sea level is etc. Flying height above the min terrain, above the max terrain, flight line separation. Hypothetical level laser scanner has these overlap values, has these footprints, has this resolution, 6 points per square meter, this many points, centimeter point spacing. It seems somewhat reasonable. After overlap, we got double, and that makes sense because this is between 50 and 66, so we cover it twice. So that looks good. The camera, overlap is good. Footprints, because I made it with a square field of view, so let me edit my camera to not have a square field of view. Resolution across track. Okay, min train, max train. Min train, max train. I made it have same field of view, but elongated pixels in one axis, so that makes sense. Hypothetical push broom has less overlap, has a certain footprint, has a certain footprint cross track, etc. 800 meters, and it has 400 pixels, so yeah, 20 meters are 2 meters rather. So this was correct. And etc, etc. I guess maybe if the value is as big as this, I would like to report it as meters as well. So my changes are... My changes that I can think of are... Are what? Are what? Guess when we summarize our input parameters, I want the speed to come after each mode. Speed there, speed there, speed there. And when we output a camera resolution, let's just say that for our camera helpers, camera resolutions, each of these in centimeters, cm to meters, and this is just cm divided by 100. Cm divided by 100 and cm divided by 100. And then generating our report. If we are a camera, I think it's better to report both. This is probably just max. And we'll do a similar thing here. So it all looked fairly reasonable from the first run, aside from Stack Overflow and a detour for tab pages not switching well. I'm going to edit my instrument configurations. Let's say that I guess that's what would expand. I would make this. So I can change all of my anchoring to make that happen nicer. Should I do it? How about I save the program? How about I say that in this window, this can be anchored to all sides. And these guys just stay to the top right. Is it gonna like that? Instead of name, that could be, well, okay, name. So my instrument configurations, did I miss? Oh, because I'm programmatically positioning this one. And therefore, I need one more thing. It's basically on resize or on layout. I need this line of code back. And it's going to be positioned to group box, location, top left, offset from top right. And this, well, then it's just right. So now that I have the offsets to the position that I position everything when the program starts, when the form is resized, where's on layout? I set the, oh, not that, but what I do is I move all my group boxes. Actually, let's see. Just all my group boxes. that, or what is it? What is location anyway? It is a system drawing point, okay. Equals this width, the form width minus the offset in x, and then it's just the y position. How's that? Let me just say how about this? Looks like I needed those braces after all. So we come over here. We see if everything is anchored, which that's pretty much what I wanted, I guess. So, anyway, let's look at our parameters for these things. Oh yes, a laser spot size is one thing we want to provide as an output. So why don't we just go do that? Why don't we just go do it? In the report, it's pretty simple, just depends on our flying height, but let's do it. If laser scanner with beam divergence. If laser scanner, it's just not consistent to what I did here, but oh well. With beam divergence, spot size over minimum terrain centimeters, and also over max terrain, and we just take the instrument, if laser scanner beam divergence, and the formula people usually do is they just multiply, because they assume this is a small angle, and they just return, let's see, parent height above min terrain, height, and they just say, oh, that's not radians, that's millirads. They just say that the spot size would be equal to I guess it's just beam divergence divided by 1,000 times the height. I was trying to think if need to multiply our 2 by 2 for any reason because of it being a radius or something. But I think the convention is just like this. So if we want to check, for example, beam divergence on the Regal LMS Q1560 is less than 0.25 millirads, and do they give any indication of the spot size? Do they have any chart? Well, as I recall, this is what you do to calculate your spot size. Just directly in. So anyhow, I mean, increase in beam diameter. That answers the question that I want to. Or radius. Usually refers to a circular cross section. Angle equals 2 times arctan, so it's the full angle, so we'll go with that. Spot size in meters is equal to that, so we have the same thing over max terrain. Then we have some strings. This is swath, footprints, overlaps, lidar, spot size. So what was it? Laser scanner with beam divergence, spot size over minimum terrain in centimeters. We are going to return this value using, that sounds fine, the number of significant digits for resolution. Otherwise, we've just got the max. So let's see. If we come now to our report, if we are a lidar, I guess just as a case here, well, we can put it here, can't we? Spot size, well, if the instrument optional beam divergence is not null, if it is specified, then we say spot size, lidar spot size, laser spot size over minimum terrain, and that is if lidar with, or if laser scanner with beam divergence. Here's this guy. Right. Laser spot size over maximum terrain. Over maximum. So let's try it. I need to refresh the form, don't I? Yes, I need to refresh the form when changing. Yeah, I guess that's what I was avoiding, but where's my radio button handlers? Why don't I just refresh form instead of doing this? Motivating case being that doing so will make sure, because I haven't synchronized the speeds that you may have entered in the different boxes into the different modes, this will make sure that when you switch the tab, the label for the speed will be correct, as well as just any other good synchronization we might want. But anyway, should we try another input mode? Let's try this input mode. Let's say we're flying at 105 knots, and our flying height is 1,000 meters, and we want a certain overlap with the camera. Well, let's edit our configurations. And this one, let's say it has a 40-degree field of view that way, and maybe 6,000 pixels. I don't know. Probably gonna have slightly rectangular pixels, but that's okay. And the push broom, maybe it only has a 30-degree field of view and has 750 pixels. I think I'll save those edits, so I'll just close the program. And while it was annoying me, and I therefore thought of it, let me look at tab order. Tab order on such a form. How is that going to work? Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The user doesn't really need to tab into those, so these guys don't need to be a tab stop. Undo. Let's go back to looking at tab order. So 1, da, 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 2, da, da, da. I guess whatever you want to do. All this stuff. Then the next tab. Oh, come on, that's stupid. Can't set tab order with that, because that is stupid. Okay, interesting. Well, what would it be? 5 maybe? So look. Yeah, this is dumb. 1, 2, 3. I don't know. This is quite stupid. Then I guess apply, revert, apply this and that. Okay, that was one round. Now the next round. All I want to do is say pow, 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 pow. Pow, 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 pow. Pow, pow, pow. Pow, pow, pow. Pow, pow, pow. Needs to be a shortcut key for entering tab order. And the last one, I did this one already, didn't I? Looks to me like I did it. So that should do that. And how does our tab order on our main form look? That looks okay. Guess 0, 1. Why not? From there to there, there, there. It's okay with me. And that's just too complicated to even read. Anyway, I'll deal with it if it seems annoying. So, right, why did that clear? Oh. Mode 2, we have a certain speed, a certain height, we choose an instrument, we want a certain overlap, and we calculate. That's too bad. If mode 2 or 3, flying height above target terrain. So we're in mode 2, so I wouldn't want to be looking at that. Mode 2 or 3, flying height above target terrain. And this is all dealing with mode 3 resolution stuff. If we are in mode 2, then we know our height. We just need to know the height above the terrain. Just kind of going the other way around with things. But what we say is, if we're in mode 2, we take our flying height above sea level, which is a given. What am I looking for? Input mode. If we are in mode 2, then our height above flying height means sea level meters equals that, and then we say that we need target terrain elevation. Maybe I get to use this after all. Well, where's the target terrain elevation? Input parameters. Mode 2 or 3 target terrain elevation. So it's good that I used this and put it in there. And then we simply return. That minus that and return it. Else mode 3. Else fall through to mode 3. So with a hypothetical push broom, we want maybe 40% overlap or 20% overlap over the highest point. Instruments, some settings. Here's our speed. Flying height above sea level. Hypothetical push broom, 20%. So let's see. If we wanted 20% with our push broom, then we got it. Overlap across track over max terrain. We should specify here that the overlap is specified over the max terrain. Report, 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 report. So where are we? In the report, in the input parameters summary, if we are mode 2, overlap for selected instrument, overlap relative to, I don't know, if wordy, but I don't care. No one complains about extra error handling. That should never occur. Unless it's code coverage, people. So let's see. Overlap is relative to the maximum terrain. Flying speed, hypothetical laser scanner. That sure doesn't look right. Laser spot size. Where are we? Spot size. Right. Meters to centimeters. Multiply by 100. Great. Wonderful. With our push broom, 20%. Let's say over the lowest terrain this time. So our flying speed is given. Flight line separation, 404 meters. This is one of the things we solved for. Overlap with our laser scanner. Alright. Hypothetical camera. Hypothetical push broom. We got this value back as we wanted it. It all looks sort of okay to me. Resolution across track, 1.27 meters. The long track is better, but that's just how we defined it. One thing we could calculate for a push broom would be the maximum exposure time. We talked a little bit about dealing with exposure times. We could have, if we have the long track information, we can figure out the maximum exposure time. Why don't we do it quickly, because I'm pretty much out of time, but for a push broom, if push broom camera with a long track pixel info, maximum exposure time for so that the pixels don't run into each other. You know, if you have if you're covering one row of pixels and it looks like this, you need to then take the next row of pixels. If your exposure time is too big, each row of pixels will be you'll have a gap. That's to say that if you're flying along and you take one row of pixels and your footprint on the ground is like that, you have a certain amount of time before you need to take your next exposure in order to get that next one. And if you don't get it within that certain amount of time, then you'll have a gap between your footprints. So there's a maximum time for your exposure, and it's relevant because if it's too low, you may not be adequately exposing your images. And also within that time, there's a relation to pixel blur. But separate from pixel blur, there's a maximum time you have if you are to achieve coverage. Maximum exposure time to achieve full ground coverage over, let's say, max terrain. I don't know if we'll calculate it for both. And what this is going to be, we need the speed. And we need the field of view. We need the footprint. How come I don't have any IntelliSense? Need my IntelliSense. A long track. If camera with a long track pixel info. Then you're gonna how many seconds is it gonna take to cover this distance? Seconds. Forwardly. Seconds to translate airborne platform distance of a long track footprint. Ho ho ho. Seconds to translate airborne platform forward a long track. The distance of one footprint equals the meters per second divided by let's see, speed divided by local footprint. So the faster I'm going, I guess that's the wrong way. And that will give me seconds, right? The meters will cancel out, and I will be left with seconds. So let's have this in milliseconds. Which is seconds times 1,000. So, one more thing, if we are a push broom camera, sorry, output I, instrument, type, Then we say maximum exposure time to achieve possible exposure time, maximum bound on exposure time to achieve full ground coverage at maximum elevation, terrain elevation. And this is going to be, I guess I want the string. Oh, I guess I'll do both versions, min and max. Over max terrain, over min terrain. Then I need some strings. Yeah, milliseconds. And it's gonna be, let's say 3 or 4 digits. Let's just say 3. And here's the value. And one more. What? What are you complaining about? What is it complaining about? I don't have two named the same thing, do I? This is min. One more. Okay, this is min. This is min. The others are max. What? This is annoying. What are the names of these? If push. Okay, maximum exposure time to achieve full ground coverage over min terrain. Maximum exposure time to achieve full ground coverage over max terrain. Min terrain, max terrain, okay. Properties exist, now give me the strings. What is it? If push broom, maximum exposure time over min terrain. So this should have been called maximum exposure time over min terrain. And maximum exposure time over max terrain. Good reason to only do one of the two, but anyway, I'm doing both just so I can make sure as a check that it's being calculated correctly. Probably comment this one. It's confusing having min and max, and they just want to know, I mean, they have to use the value that covers the full terrain. The upper terrain is the limiting factor here. Okay. Maximum bound on exposure time. Woo! But let's just have a look. What is my field of view in the along track direction? .01 degrees. The footprint is just 11 centimeters. And looks like I have this wrong resolution along track over max terrain. So let's see. I wish I could work. Well, I mean, I don't care about edit and replace. Edit and replace, who cares? I mean, edit and continue is what I don't care about. Actually, I don't like that. Who cares about edit and continue? I don't want it. Just let me edit my code. No. So anyway, why was this apparently wrong? Over maximum train. Aha. That was straightforward. Test for reasonableness. All right. Where's my push broom? So if I'm going 50 meters a second, how long is it going to take me to go 11 centimeters? I'm going 0.1 meters and 50 meters a second. I mean, I'll cover that in that much. So I guess that's right. That's the maximum exposure time. I guess maybe it's more common to specify this in microseconds. I mean, I forget. If we look at a high specs instrument, I guess they more often specify exposure in microseconds, which is crazy. But anyway, so I am about out of time for today's session. It's cool that we got the report generating. I mean, there's some simple things like save this as a text file, but I was thinking about having an HTML representation of the report. I'm not certain if I'll do that. Not certain if I'll have another video session on this program. Maybe after a break, maybe after a week or so, I'll get back to just tidying this up. But anyway, thank you for watching. I hope you enjoyed me programming this tool that's useful for planning the parameters relevant to aerial survey. There is one more thing we need to do, isn't there? We need to check if mode 3 works. So we choose an instrument. We want to achieve 25 centimeter point spacing at worst after taking multiple passes over account, and we are allowing ourselves to fly at 77% overlap just because I want to see. And it says that we can fly I guess here I need to specify achievable after. Why don't I do it while I'm thinking about it? In the input summary, mode 3. For the min terrain or max terrain, but pixel resolution now I also need. If overlap enough, if applicable. And no. Before overlap. Otherwise, just working quickly here. And ay ay ay. We are about finished. Just about done. Just about finished. So with my laser scanner, I want 25 centimeter point spacing at worst after taking multiple passes into account. So overlap with the min terrain, 77%, because that's where we wanted to achieve. So that's interesting, but it just comes from that. So anyway, over max terrain, footprint across track over min terrain, footprint across track over max terrain, resolution over min terrain, resolution over max terrain. So we got this over the min terrain. And after overlap, what did I want anyway? Using the hypothetical laser scanner. And with with that hypothetical laser scanner, I want 25 centimeter point spacing. But after round tripping it, we get quite a bit more than that, quite a bit better. Or do we? No, 25, and that's what we specified. That we wanted. We wanted 25, we got it. We got it from a single pass. Uh-huh. But it's okay to get it after overlap. Did it... when we calculate our effective num points per second on the laser scanner, you know, when we solve for our height is really where this is. When we solve for our height, let me do this. Flying speed, good. Points per square meter, 16, that corresponds to 25 centimeter resolution. Now this may account for higher than whatever overlap. So let's see. No, I want to step in. That was dumb. In debugging, I want to step into properties. Where are we? Where are we? No, don't step over properties. And I don't like this either. So we'll just try that again. I guess we get the chance here. Here we go. 400,000 points per second. The resolution mode should be after considering overlap. After considering overlap. Our fraction is 0.77. Our multiplication factor is 4. So, look at that. Look at that. Well, anyway, 77% with this hypothetical laser scanner. Off we go. And we solve for a certain amount of overlap. Aha, that's better. With so much overlap, we only need this many points per square meter from a single pass, because after so many passes, we achieve it. So our flying height should be quite a bit higher than it was before. Good. And anyway, it's okay with me. If we try again, saying this, then we have to fly quite a bit lower. And we get much better point spacing after all that overlap. And if we say this, I would like to have an example where there's a lot of terrain variation. And do we have a bug where I mean, you always, I don't think we entered the min and max terrain elevations into our flying height calculation. We just took it, we need to be a certain height above the min terrain, but actually, so why don't I just add a warning? But anyway, if the max terrain is this huge thing, and I say that I want a certain point spacing or centimeter resolution over the minimum terrain, well, it might put me low. And I don't know, for example, overlap over max terrain, 107%. Negative values with some nans. At least it didn't crash. Guess what I'll do is I'll just say, what can I say? Rather than spend too much time on this, I'll just say if output flying height above sea level less than input arc parameters max terrain elevation less than or equal to, really. Warning. Salt flying height is less than maximum terrain elevation. You have a problem. So if we just run it again, warning, probably be more bold, but anyway, let's say with my push broom I want a negative 5% overlap and 50 centimeter pixel resolution. That results in still some overlap for the laser scanner, but negative overlap for the push broom. And what else? So yeah, let's see, this isn't really so crazy. Over min terrain, over max terrain. Interesting, our flying height is just flying height above min, flying height above max. Anyway, I think it checks out. What's going on here? Are we below the max terrain? Should be above the max terrain. So, why did we see this happen? Okay, so there's a problem here. It's after considering overlap. So what? Right. There's no penalty, so to speak. I need special handling if the overlap is negative, and that's okay. Because the overlap could be negative. So we come, for example, to here. This is referenced in more than one place, right? Looks like several places. So we're all using the same thing. And yeah, this is in the input parameters. That's what I wanted to make sure is using this function. So if the overlap, what am I really saying here? I mean, as well as the fact, if it's, let's say the overlap is 30%, then the strip lateral contribution is 70%. The reciprocal of that is 1 over 0.7 equals 1.4. You round that, you get 1. So it's really only this case I need to handle, which is consistent with what we've seen so far. Assume minimum 1. Or 1 if overlap negative. Because technically the minimum times we cover the ground in that case is 0. But that isn't what we want calculation-wise. So we'll just sign that. And anyway, we are pretty much finished. So thank you very much for watching me program over the past 25 hours or so. This tool for planning aerial survey mission parameters, and we've enjoyed making this tool, and it was motivated by real work that had been done usually with spreadsheets. This might provide a useful alternative to bolster and support such spreadsheets. Just cross-check, I should say, cross-check such spreadsheets. And anyway, hopefully it's useful and doesn't crash. And so, thanks again.